Okay. And we'll hope that this is working. Okay. Yeah, so SPSS is a super expensive program. Does anybody know how much it costs? About $1,400 a year. You have to buy the license for it. It's a yearly license. Anybody know how much Minitab costs? Roughly about $50 a year for students. And I think that Minitab does a better job of creating statistical outputs that are much easier to read. So, okay. I'm gonna play around with some assessments today. We have time. So we're gonna do talk about reliability. We're gonna talk about validity today. Two important measures that we have for our assessments, and then we'll mess around with some assessments. So, did everybody get to see that the vignettes have been put on D2L? Your vignettes are on D2L now. So I uploaded them last week. So you can take a look at them. You can start reading them and figuring out what assessments you might want to use for your final project. So, any questions or concerns about that? Okay. All right. So, reliability, right? Here, let's see if it works. Just it's so incredibly hot right now. What do we know about reliability?
Isn't it the ability to complete the same test and get similar results each time?
Yeah, absolutely. So reliability tells us that a test is going to be measuring a construct over and over. Did that just go on? That's awesome. I think we did it at 5 o'clock, they turned it back on. Yesterday we had no air conditioning and all of A-Wing, maybe it was just A-Wing. So it's nice that we have some air conditioning in. Yes, so reliability is the ability to measure the same construct over and over and over again. Why is this important?
Otherwise, your test is meaningless.
It's meaningless?
Well, if you can't replicate the same result each time, then what are you really learning?
Mm-hmm. Yeah, what good is it if it only happens every now and then? So if we think about things, what is something that we know in our lives that is replicatable or has good reliability?
The sun coming up.
The sun coming up every morning. Has it happened every day that you've been born? Does that mean that it's going to happen every day following? No, it doesn't mean that. But chances are good that it's going to happen. What else? That's a good one. What else? What else is reliable? You can count on me cursing in class. That's pretty reliable.
I was gonna say, like, if you have a scale that actually works, you should pretty much have about the same weight. If we're gonna go into tests like intelligence tests, it's pretty reliable.
Intelligence test. Yep.
As well, they're pretty reliable because you're gonna get the same result, even as you age. It's not really going to change much.
Possibly, right? Even like the sun coming up doesn't mean it's going to come up every single day, right?
Yeah.
But in our lives, outside of assessment and testing, what's reliable?
My car, Honda.
Your car, it's a Honda.
Yeah.
Hondas are reliable up until when?
Up until maybe 10 or 12 years out, it might start.
About 300,000 miles, they start to get a little wonky. Okay, so there's reliability to a point. Right? So far I haven't heard anything that's 100% reliable.
You getting older every day?
Oh, snap.
To a point.
To a point. Can I stop getting older right now?
You die.
Yeah. What if I had a massive heart attack right now because I had a Dutch cheesesteak from Dino's Wangs and Bangs? It's like all the place. Wings and things, but I like wangs and things. And what it is, it's a cheesesteak that they put French fries in, cheese, and then brown gravy all over it.
There's worse ways to go.
What's that?
There's worse ways to go.
There are worse ways to go. So I always feel bad for my vegan friends. Eat everything vegan. That's good for them. I'm glad they're all healthy, but they're missing out on things like bacon and gravy. And bacon and gravy together.
How about gravitational fields?
Gravitational fields, right? Except that we know that even those become distorted. Einstein's theory of relativity is somewhat in flux right now. By whom? Stephen Hawking, right? What he's looking at, he's talking about wormholes and ways to distort gravity and time to maybe travel. I watch a lot of Nova. Sorry. What is 100% reliable? There's one thing that I know that has never been defeated, and that's death. It's 100%. There's a 100% chance that you are going to die at some point. Right? That's it. You know that there are more dead people on Earth right now than there are living people? That's creepy, right? It's the only thing I know that is 100% reliable, that we will die at some point. And who knows, maybe that changes as well. Right? What are some things that are always unreliable? The weather. Yeah, the weather is, or the weather person is fairly unreliable. Is weather an easy thing to predict? What's that? Absolutely. You could be way wrong. Way wrong. Why is being a weather person, why is it unreliable?
Weather is impossible to predict more than like.
Hold on, wait. The first part of what you just said, I know you're about to go on, but you're saying weather is impossible to predict. We have Doppler radars out there. We have airplanes, they're called AWACS airplanes. I know I watch a lot of Discovery Channel too. AWACS airplanes that fly into storms so that they can predict exactly what's happening, right? We have, I don't even know how many satellites are watching cloud cover right now, and condensation, and vapor trails, and things like that to find out what the weather is going to be like. And yet, it's impossible? You're telling me we spend tens of billions of dollars on all of these instruments, and we still can't predict it? And yet, I have a piece of paper here that can predict something in human beings? Reliably? Not only are we going to learn about assessments in this class, but we're going to learn critical thought about assessments, right? It is so difficult to predict. It is so difficult to have reliability when we're dealing with things that there really is no reliability built into it. There's no reliability in weather. It can change in a minute. What it's doing right now here may be completely different 15 miles away from us. Just like what's going on with you right now could be completely different with the person sitting next to you. Even though we all sort of kind of look the same. We all have mostly two eyeballs, right? We all mostly have a head. Right? So we're all similar in a way, but we're so very different. And yet we spend tens of millions, maybe not billions, but tens of millions of dollars on these on a regular basis to try to predict and come up with reliability. And so the reason why I'm asking you this is because not everything we're going to see is going to have great levels of reliability, and that's okay, right? Because it might be the best thing that we have. And then when you see things that have really great levels of reliability, be super skeptical about that. Because even the weather can't be predicted well, at least reliably. So reliability refers to the degree to which a test score is dependable, it's consistent, and it's stable upon additional testings. And so what that means is that I have brought with us today the Connors 3. This is the self-report. So what this means is that if I give this to you, I should be able to give this to you over and over and over again for at least this period of time, and the answers that you give will be relatively stable. There will be some fluctuation, a little bit, depending on the day, depending on what's going on, depending on the weather, depending on if the sun rises. There's going to be some difference, but typically there's going to be stability in it, maybe. Multiple factors can impact reliability. Reliability refers to the results obtained, not the instrument itself. So when we start talking about reliability, we're talking about the output of these tests. We're not talking about the physical test itself. Although we are going to look at this test and we're going to maybe come to a conclusion of whether it's a reliable test or not, just based on construct validity. Well, that's going to be validity we're talking about in a bit, but looking at the reliability between this and the teacher's version, right? And this and the parent version, because all three of these measure the same exact thing. And it's going to be like a holiday for you guys, whether it's Christmas or Hanukkah or Kwanzaa, and we're going to open it up, and inside, all of these papers are just going to fly out. It's going to be so much fun, I promise. I hope we have a good time with it. I know I always do. Has anybody used these before, the counters? I do ask that you don't write in them. They're super expensive, and I need to use them for another class. So we're not going to be administering them. We're just going to be taking them apart. We're going to be looking at them. We're going to be studying them in a little bit. But I do need to make sure that they get to the next class as well. So. Measurement error. So measurement error is any fluctuation in scores that are results from factors related to the measurement process that are irrelevant to what is being measured. So what are some examples of measurement error that we may see in testing?
Tiredness, depending on the time I took the test, the person that administered it,
Okay.
it's an error within itself.
Well, administration should be standardized, right? So, but there's definitely going to be some fluctuation. There's going to be some fluctuation between that. What about time? So if I give you a test on, what am I going to be a test on? Statistics? I give you a stats test at 8 o'clock tomorrow morning. Versus I give you that same test. Oh, you have a choice. 8 o'clock in the morning versus 3 o'clock in the afternoon. Which do you think you'll do better at the 8 o'clock or the 3 o'clock? Why 8? Oh, you said 3. I'm sorry. That must have been confusing. Why 8? I don't know. I said 3.
Your mind hasn't been so stressed out and taken in 1,000 different places.
Okay.
At 3 o'clock, my mind's exhausted and I can't focus
Okay.
on things.
So mornings. How many people say 8 o'clock? How many people say 3 o'clock? How many people don't care? Oh, really? Just kidding. How many, so of those, if you were an 8 o'clock person, please raise your hand again. Of those people who are 8 o'clock, or how many of you are morning people? Leave your hands up. One of you isn't a morning person. Of those people who are 3 o'clock, raise your hands. Keep your hand raised if you're a morning person. Look at all those hands go down. Right? Yeah, absolutely. So based on what time is your preference, you're going to do better or worse. I am a morning person. I get my cups of coffee, and I don't drink coffee in the afternoon. I become sluggish. But most of my energy, especially cognitive energy, is built up while I'm sleeping. So I'm a morning tester. I will always take tests at 8 a.m., not 3 p.m. That's awful for me. It's never good. So, which then begs the question, why am I teaching at 5 o'clock? Because really, I should be teaching at like 4 in the morning. But anyway. Times that you take the test are going to equal measurement error. What else?
Weather.
Oh yeah, the weather too. Absolutely. Yeah, weather, depending on whether it's a nice rainy day, right? And often that is confounding, right? So if it's snowing, sleeting, shitty weather out there, you're probably going to have a difficult time getting here to take your test, whether it's at 8 o'clock or 3 o'clock, which is going to evoke some kind of level of stress or anxiety, which then is going to translate into you probably not doing well or as good as you could on the test. So that could be part of the measurement error. What else?
Whoever's reading the test.
Whoever's reading the test. Yeah, sure. How many people have those? How many people have had those professors that? Yes, you had those. They kind of just drone on and on and on, and they take the book and they're like, the Connors 3 normative sample is divided into 2 groups versus, right? And so if somebody is reading those directions, you may find that to be distracting, or you may find that to be actually soothing, and it works well. You need, it depends on the person. It depends on your personality. What else?
Any personal issues going on recently?
Wait, but you're a human being, especially a human being in a counseling program. You're not allowed to have personal issues, right? You're supposed to just solve them all yourself. Okay, so there's personal issues that might be going on. I sometimes like to call it life. Life happens a lot. What else?
The setting.
The setting. Yeah, Dr. Reddicott's having class in the basement today. How cool is that? Yeah, right? I was like, oh, see it. I was like, hope there's no radon down there. That would be on my mind the whole time. Radon, right? Although I don't know if there's radon in the building. I'm sure there's worse. Maybe not. But yeah, setting.
How much you slept the night before?
How much you slept the night before. So I'm hearing all of these different issues that could cause measurement error. And all of them can happen to any of you at any time during your life, or you can have multiple factors affecting you for the time that you take the test and the assessment. So if we're talking about reliability with this assessment, right, we're saying that it has to do with the score. But your score is wholly dependent on what's going on in your life, and how much sleep you have, and what you had for breakfast, and how many cups of coffee you had, and what type of coffee you had. Because Sunoco has like double caffeine coffee. It's just the best. So measurement error could also be understood as the difference between the individual's observed score and their true score. We're going to talk about that. When we talk about observed and true, you won't get both of those scores when you give an assessment. You're only going to get one. But the observed score is going to be the actual score on the test, where the true score is going to be the reflection of one's ability, skills, or knowledge. So your observed score is true score plus error. So meaning that, so how can you interpret this differently? Does it make sense, or am I making too much of this? Sometimes have a tendency to complicate things. So what are you going to get when you test somebody? You're going to get their observed score, absolutely. Their true score is their potential. Their true score is what they could have scored had there been no error, had there been no snow, had they had as much coffee as they needed, had they gotten 8 hours of sleep, had there been no personal issues in life, right? That would have been their true score.
How do you guess that, how would you know the true score? You don't. You just hope for that.
Well, how can we figure out measurement error?
Have the same person take the same test over and over again across time.
Yeah, that's exactly how you do it. You would do test retest over and over and over and over again, and then you would just take the average of that. Right, and we will see fluctuation. So let's say that I give a test and somebody scores a 68 on it, and then I give them a test and the next 3 tests they score 96, 96, and 98. What does that tell us?
They're having a really bad day on that 68 day.
Something happened. There was some sort of measurement error there. And what we're getting closer to is the true score, right?
Is there a certain amount of tests you're supposed to retest them on? Is there like a magic number?
There is no magic number. I wish there were. I mean, if we were to go statistically, I would say 65. I know that sounds like a lot,
I was going to say that does.
but 65 is the point of satiation for correlation. So typically, if you're going to do a correlation study, you want to have an N of at least 65 because then your observational power is greater. And so the more scores you have, the closer you'll get to the true score. You'll never get to the true score because there will always be some sort of measurement error.
And how long do you wait in between each one? Like, what's the interval?
Again, it all kind of depends, right? Now, if I were to give you a 10-question test on statistics right now, and then I gave it again tomorrow, and then the next day, and then the next day, and for the next 90 days, they gave it to you every day, what do you think would happen with your test scores? Yeah, they would go up because you would memorize the questions. And at some point, you're just circling whatever the answer is in the multiple choice or writing in the answer. You know what it is. And so when we test, which I'm not sure if we're going to talk about this today, when we test, we want to make sure that the testing is not done too close together where people are just memorizing the answers and answering it accordingly. But we also don't want to make it too far apart where people's knowledge base is shifting and changing. For example, if I asked you about statistics from last week, you guys would have a baseline score. If we came back next year at this same time, I was like, all right, let's have another test on stats. You probably all look at me like, well, I thought we were done with that because that's somewhere back there.
My understanding of the true score is that even though by subtracting or figuring out the error, it's a hypothetical construct, there's no real way to really to know the true score. You just
Absolutely.
have an idea,
Mhm.
but there's so many variables to really say, okay, this is the true score. So it's more like hypothetically.
Yeah, that's exactly what it is. Will we get it's almost like the bell curve, right? We'll get close to a normal curve the more data points that we have. We'll never get to 100%. We'll get to 99.9999 at some point, and we'll get into a very, very, very close range of where that person, a very tight range of where that person may fit with their true score. But yeah, absolutely, because there's no such thing as a human being in a vacuum, right? We can't just take all of the problems, all the issues away. That's what being human is. There's suffering that's involved with it. There's difficulties. There's just life. That's part of it. So here are some sources of measurement error that we may find. So time sampling error, which is kind of what we were just talking about. Content sampling error, inter-rater differences, and then other sources of error like quality of test items, the length of the test, test taker variables, and test administration. So just talking about these real fast. Everybody, assuming that you read about the time, content, and inter-rater differences. When we talk about quality of test items, what are some things that we're looking for? What are we talking about there? Or do you like milk? Or is the room comfortable right now? Was that difficult to answer? Is that a difficult question to answer? Why?
Because you're asking a lot of different things all at once.
Yeah, I'm asking a whole bunch of different things at once. Absolutely. We call them compound questions. And that's one of the things that we want to look for in the quality of the test item, right? The test item meeting the question itself. Is it asking what it's intending to ask, right? If I ask you, do you drink almond milk, and I really want to know if you find the temperature of the room comfortable right now, I'm never going to be able to measure what I want to measure because it's not asking the right thing, right? Same thing as if I ask you a question that has ands or ors in it. Whenever I see an and or an or in a question, I automatically reject that as a quality issue because you're obviously asking for you're trying to measure two different things within one question.
Could you explain the difference between content sampling and quality of test items? They seem to be like overlapping.
So content sampling error has to do with the actual content of what's being asked. The quality of the test item has to do with the construction of the question itself. So the other sources, these are all things that we really have at least quality of test and test length, we have the ability to control those things. We have quality of test item issues because we have people who do not ask others to read over their work or edit their work. And so they just put it out. I was going to bring in I have an imposter scale from 1985 by, I believe it's Lowry's scale. And it is very poorly written. And if we look at the psychometric properties, it's said to be one of the most sound psychometrically sound assessments for imposter syndrome out there. But I can't even understand how that's possible because almost half, if not more, of the questions are compound questions asking two different things. So we need to be really careful with that. And test length as well. How long should a test be? 1 page? 6 fonts? Little tiny? Depends on the test. How many items do you think should be on a test?
Well, I mean, just from reading the book, it says that the more questions you have, the higher the reliability on it. But then if you make the test wrong, it's going to be subject to time sampling error.
Absolutely. And so here's the psychometric property, right? The psychometric problem with some of these assessments. You're 100% right. I can have a test like the MMPI that has over 356 questions right now, and the psychometric property is fantastic. Because what I do is I take out all of the questions and I do all of these different types of tests to see what the reliability coefficient is going to be. We're going to talk about the validity coefficient. And it comes out superb because we're asking the same question over and over and over and over again, right? And so as long as the person's being honest and truthful with the assessment, it is great. How long do you think it'll take you to take a 360-item test? A A long time?
That's 3-4 hours.
3 or 4 hours? By the way, how many people see their counselors or psychologists for 3 or 4 hours to take these tests? What do we typically do when we give somebody a long test like that? Or what have I seen? I shouldn't say I don't do this. Go out in the waiting room, and when you're finished, just give it to the receptionist. Yeah, talk about measurement error. Yeah, it's a long time. You lose concentration, you lose focus, although with the MMPI, that is kind of the whole point of it is for you to allow your defenses to go down because you're so tired from taking this questions over and over and over again that you do automatically start to answer them correctly. No more than 30 items is where I usually say on an assessment. Once you hit 30 plus, now you're starting to get into a fatigue zone where your readers are going to not want to probably take the test. And that's one thing that we see often. So I use, for assessments, I use a program called Survey Gizmo. Does anybody know Survey Gizmo? What's the other one that everybody knows? Survey Monkey, I think it is. That's usually, it's free, I think, so I think that's a popular undergrad. Survey Gizmo is really nice because it will assess your assessments and give you a fatigue score so you know how fatigued the person's going to be or how likely they are to quit. Has anybody ever taken an online survey and then you quit halfway through because the questions are just ridiculous? Yeah, that's test length right there. So we want to make sure that we're not doing that. So, some methods of estimating reliability. So the most common method of estimating reliability involves correlating two sets of test scores to obtain a reliability coefficient. And so we want to look at scores and see how they correlate with each other. I mean, intuitively that makes sense, right? That we're going to test, I give everybody a test in here, and if you all score similar to that, whatever construct I'm trying to measure, then we can compute a reliability score, and it may be something that's good. So let's take a look at this. Do you guys remember R from last week? So reliability coefficients relate strictly to groups of test scores and cannot be applied to individual test scores. They measure on a scale from 0 to 100. The closer to the coefficient, the closer it is to 1, the more the score approximates the true score. And so the error is very similar to this. True score plus error equals the observed score. And so we've just done the opposite. We're saying error is 1 minus R. So if I have a correlation of 0.90, that is a really nice correlation. How much error do I have? 1/10, or if this is 90%, it would be 10%, right? So it's very easy to figure out how much error is built into a test. You may see questions like that. When you write assessments, you typically want to write in that way. You want to talk about the amount of error, not about the amount of reliability that's in there. So how do we measure? Well, we were just talking about that. Test, retest. That's one of the basic ways that we can do it, where we just test the same assessment over and over and over and over again to see what comes up. Connors, the 3rd edition, right? So when we're talking about reliability, they did a lot of test, retest. There is the self-report, there is the teacher, there is the parent. I know you don't know this. Take a guess. How many times do you think they test, retested this? Once? No. Actually, many, many, many times. This one test had an N of 1,200 people. That's a lot. This one, 1,200 people. Self-report, 1,000. So these have been tested over 3,000 times. So when we look at their reliability, we can say that it's, if the reliability does come out, that it is reliable, that it is fairly reliable. Alternate forms, and so this is, so what's an example of an alternate form?
Like the same test with like questions in different order, worded differently.
Yeah, and so we could use inverse to find out. And oftentimes we'll do that. We'll ask a question in 2 different orders to find out, well, sometimes it's called positive and negative.
but we'll score them exactly the same. And so what that means is that when you go to do your hand scoring, you have to invert your numbers as well. And so let's say items 2 and 17 are one's positive, one's negative, asking the same exact thing. They score 2 and a 3. Well, the 3 we have to invert to a 2 because it's asking actually a negative question. So you have to be very careful when we're using positive and negative questions that we're scoring them the correct way. And then we have internal consistency as well. Split half, or the Cotter-Richardson formula, and coefficient alpha. Split half is typical what we do, and we literally split the test in half, and we give the 2 halves to see if they're correlated as well.
So what is it that, I mean, when she answered, it was a description of alternate form. So what would be like an actual example, like something specific?
Yeah. So if I were to ask you, I mean, anything that it would just be antithetical to whatever the question is. So what's a question that we can ask for an item? I'm really bad about being on the spot, but I can figure out the inverse.
Can you say like on a scale of 1 to 10, how happy are you?
Yeah, that's what I was gonna say, but I'm trying to stay away from the happy construct, because then what's the opposite of happy? Is it sad? Is it? Okay. So if I were to ask, like, true or false, today you're, feeling happy, and then I would say true or false, today you're feeling sad. I want to see that those have 2 different answers, right? The 2 different answers will give me reliability. So if you tell me that you're happy and that you're not sad, then that's a reliable set of questions. But if it turns out that you're happy and sad, what does that mean, right? It means that my test is not measuring something correctly.
So in alternate forms, you're always like testing something that should be the opposite of it.
It's not always. Alternate forms can be anything that is going to be testing the same construct in a different way. So that might look like putting it into a different setting. It might look like rearranging of the questions. It might look like a few things. Oftentimes what we'll do is we'll test it with different groups, right? And so if I create the depression inventory for adolescents, I'll also give it to adults because I want to see that they're not related to one another.
So it's like the other test that you had us use where they were asking questions, like, I don't know about the question, I mean, I'm trying to think, like the media questions, like, how often do you wake up feeling really active, and then like, I guess they would ask the same kind of thing to word it differently.
Yes, absolutely. We'll see that in the Congress today. When we open this up, you'll see questions that ask something along the lines of, your child displays boundless energy. And then 12 questions later, it'll say, your child is lethargic. These are all lighter scale questions as well. So it's more than just true false. It'll be lighter scale so you can actually see the statistic of it. And so this is from your book, so you can take a look at this. It has all your information in there as well. So selecting a reliability coefficient, what are the potential sources of measurement error? And does the test measure one or more than one construct? And this is what we were talking a little bit last week about factor analysis and looking at tests to make sure that it's not measuring more constructs than it's supposed to. I'm going to just compare on real fast. So for example, I'm working on an assessment for mentorship right now, and through factor analysis, it should only have 3 major factors, that being of the counselor, instructor, or peer roles. Underneath it are different content for each construct. But what it is it's taking larger sets of data and boiling them down to their smallest factors. So our level of acceptable reliability, it depends on the construct that's being measured, the way the test scores were used, and the method used for estimating the reliability. But typically, this is what we're going to go with, and this is what you guys will go with as well when you're working on your projects. That a reliability of 0.9 or greater is going to be very high. High is going to be 0.8 to 0.89. Acceptable, 0.7 to 0.79. Anything under 0.7 for what we're doing, not really acceptable. Which is different than just talking about correlation. If we're talking about Pearson's R, or we're talking about a correlation using Pearson's movement, right? What would be, where does the acceptable level start? About 0.5. 0.5 is moderate, 0.8 is pretty high, right? So when we're talking about reliability coefficients, it's a little bit different. It's skewed a little bit more stringently, so so please be aware of that.
Just for if we want to have an assessment for our final project, but we don't see reliability coefficient, are we still allowed to use it? Or?
Yeah, but you gotta worry about it.
Yeah,
Why
yeah.
it doesn't have it. You gotta do the history, find out the history of it. Yeah.
Okay.
Here's what you really need to be careful of with this, is that you will read the minimum measurement yearbook, the MMY, is that they'll say it has a very high reliability coefficient of 0.80. That's what it will say. Or it'll say it has a high of 0.65. 0.65, right? And so that's where you have to be careful, because I'm asking you to use this set of criteria. You can go out there and look through the literature, especially the statistics literature, and you can find another set of reliability coefficients that are different from this. And so what some people will do when they're writing up these reports is they will go and find their favorite author that has talked about reliability coefficients. If it fits what they're trying to show. So statistically, there are some things that we do say are constant. For us, we say a p-value of 0.05 is where we start seeing statistical significance. But that's arguable as well, depending on different factors. So just know that the person who's writing this knows that. They know how to write these in a way to make it look the way that they want. So they may say that it has a very high coefficient level at 0.7, but what we're using, it's not. It's acceptable, but it's not high.
So, because when I saw it in the textbook, I'm seeing how you're like teaching it a little different. So I want to know if it's what I saw in the textbook and what you're saying, it's like both. So from what I'm hearing from you is that these are like, I guess, the standard.
Oh, I'm sorry. Yes. This is what.
For what the type of test that we're doing.
This is what your book is giving you.
Okay.
And so because I'm not going to give you all the literature on all the other ones that are available, that's why I'm asking you to use this one.
Because when I read in the book, it was more like while you're administering your test, if you are someone like with this test, presents a high risk for the individual, then the validity should be like very high, at like 0.9 or greater.
But
No, that's why I'm asking.
we're not to validity yet. We'll get to validity.
I'm sorry, reliability. Reliability. So it was kind of saying that when they presented that little table, it was saying that if you're going to administer a test to someone and this test presents with like very high risk for them, then following this table, it wouldn't 0.7 wouldn't be acceptable for them. It would be like 0.9 or greater because it's a very high risk. So it needs to have a very high reliability of 0.9.
Yeah, I'll have to look. I don't remember reading that specifically because reliability is a general concept. In high risk, what do we mean by high risk?
Well, the way it said it, it was just like that, like a lot fell on that person. At least that's how I read it. I'll look at it and I'll show it to you.
Like, do you,
Let me see.
okay, like if we're going back to measurement error, if there's a great deal of
So, yeah, they put like an example high stakes test.
high stakes tests.
Yeah, if a test is being used to make important decisions that
Yes.
significantly impact an individual, example high stakes test, reliability coefficient should be at least 0.9. So that's what I'm asking.
Yes. So
Because that's kind of like how I saw the table. Like, okay, well, for something really high risk, then I can't be like
not high risk.
1%. Well,
High. There's a huge difference. So what is high stakes testing?
there's a lot. Like it impacts. Okay.
School counselors. What is high stake testing?
Oh, there's a lot of like money from the government riding on the answers, the scores on these tests.
What is our high stakes test that we use here in Pennsylvania?
PSSA.
PSSA keystones. The keystones. What does the keystone determine? Why is it considered high stakes?
that's, if the students don't do well, like, the schools don't get money.
Absolutely. Your school district will not get funding at the level they want if their tests are too low. The higher the score is, the more funding they get. The lower the score, the lower it is. Also, what I just found out because I was talking with some school counselors is that not PSS, Keystones are used to evaluate teacher performance. And if you as a teacher are not doing well with your students, are not doing well, like you can control how well your students are gonna do, right? Then you can actually lose your job.
It's like we get like a sort of like a pie chart.
Uh-huh.
My kids actually don't even take Keystone, so it's really funny that I get graded on it. I actually do passive.
Okay.
That's life skills and everything.
Mhm.
But I still get a score in hopes that all my other teachers are doing a really great job of making sure their Keystones are great. And the other thing is our kids now can opt out of the Keystones, which throws a whole other like
Mhm.
thing to that loveliness.
Yeah.
They can opt out.
Yeah, they can opt out of it. You could, like, so like if you get below basic, you could, it still goes on there like, and transcripts,
Mhm.
but I guess colleges don't really care. I don't really know, I'm not in the admissions part of that part, but I just know the kids are opting out, which then throws
Mhm.
like a percentage into, again, the government funding.
Mhm.
But yeah, it's like, in October, we all get like our little pie chart and it
Mhm.
says, hey, you guys did really good here, and here's an extra point for, hey, you didn't,
Yeah. And if you're at a private school, you don't have to take it.
or charged.
Or a charter school,
Yep.
you do not have to
Yep.
take it. When we had a foster kid, we put her in Catholic school because it was the only private school around, and she was able to learn all year. She didn't have to get taught the test. And so we call it high stakes because if our students don't do well, there's people lose jobs, funding, millions of dollars of funding can get cut. So then what does that mean? It's that we, as teachers, start teaching to the test. No longer are we teaching you what you need to know, we're teaching you how to pass this test because I need this job, right? And so the reliability of that has to be super high because if we're going to make decisions about finances, especially when we're talking about hundreds of millions, maybe billions of dollars of where it's being distributed, and we're making decisions on who's keeping jobs or who's getting promoted, and so your book is right in that we want to make sure that there's a super high level for that.
So do they have high stakes tests for like individuals? Because when I saw that, I just thought about an individual. I didn't think of something else.
Well, every individual does take it, and then the school gets to decide what they want to do with their keystone. So it's my understanding that there's sections on the keystone, and that if you don't pass certain sections, it may impact your ability to graduate, or it may impact what classes you get to take in the future, things like that.
Like the remediation classes, you're allowed, you can take like, some of your remediation classes and take it again, but then you could eventually opt out if you'd like. And just, I don't know of any teacher that actually likes them.
Yeah, no.
None. Everyone hates them and they think they're ridiculous. And then, but the government tells, because they're funding the public school systems, so they tell us that. I'm glad I don't have to do it. Like my stuff's completely functional, so it makes much more sense. But it's, but some, and even some of these tasks talking about time and all that greatness, it, like, for example, some of my sophomores, not mine in particular, are taking 3 of these high stakes tests in 1 year versus like taking like maybe 1 in freshman year, 1 in sophomore year, or they take their biology in like junior year, but they have biology sophomore year. So it's like us taking statistics again next year, which we would fail.
Right,
And
again.
so, well, would not be in our heads.
Right? All of these things enter into it. And so, but yet, for some reason, this is what we do as a state. This is how we determine whether students are proficient.
I was thinking more of if I had a client and they're going to court or something, so they're like, their stakes are high, that they need to score a certain way. Like, that's what I was thinking.
Okay.
And I was thinking of an individual, and it's like, this test has to be really reliable because, like, this person's life is on the line.
And we want to always make sure that we're using very reliable tests, especially if you're going to do any type of forensic counseling and you're going to testify in court, because what you're doing is you're testifying on, that it is what it is. Not that they're going to throw you in jail if it's not, but that's your credibility. The likelihood of you being asked back to testify is going to be nil. And I've done that before. I don't know if I told you guys, I had a friend who is an attorney general, is now going federal, he's coming out of DC, but he'll give me reports from psychologists to see like if they're doing stuff that is like on the up and up or if they're not reliable. I tore this one person apart. He was able to take that in and get the person discredited as an expert witness because of that. So so you definitely want to make sure you know what you're doing with these things. Now, for us, what we're doing normally, this is just going to guide us into selecting assessments that are appropriate. And then I think we're almost at the end here for this. Standard error of measurement, or SEM, measures the individual's test score fluctuations due to error if he or she took the same test repeatedly. So you're never going to score the same all the time. So SEM is just going to be that variance, that range between that we normally fall in on any given day. Again, if I test you on a Monday versus a Friday, we're going to get different test scores. 8 versus 3, different test scores. 90 degrees versus 0 degrees out, probably different test scores. I think you'd probably be more alert if it was colder. We should try that sometime. All right, research. It's not a measure of reliability, but it can be used to create confidence intervals around specific observed scores. And you'll see that often when you see two scores, it'll say confidence interval, or CI, equals 97. And what that means that it's, if you see like 97% confidence interval, that means that there's a very good chance that if they were to score, 97% chance they would score within that range again. So you like to see confidence intervals that are really tight and really high in your numbers, because that indicates that it's pretty specific. And so ways that we can increase reliability or the precision. So increase the number of test items. Again, not always great. I mean, this is in a vacuum. If you increase the number of test items, you will increase reliability. But what else might you do if you increase the number of items? Yeah, fatigue.
Yeah.
Right, we increase test fatigue, and the likelihood that somebody's just going to be like, no, I'm done with this. I'm done with this test. Right understandable. I mean, isn't that great? Like, write items that are understandable, that lack ambiguity. Right? It's so difficult to do that. I know it sounds kind of crazy, but that's one thing in my doc program that they had us do in class. We're like, all right, write 5 questions that you can make. And we're like, oh yeah, it's super easy. Over half of us had double barrel questions. We had compound questions. We had questions that were asking things like, what makes you, what is happiness? Like really like things that we should all know better, but when you're just writing, it's often just like, oh yeah, let me ask this. And so it's always good to have a group of people when you're making assessments or you're reviewing assessments, a group of people that can help you read over your items for you. So that way you can have a discussion about what is it that I'm trying to ask. So one of the things when I'm creating an assessment that I do is to make sure that I'm writing understandable questions is I will ask the question in 4 different ways and put that within. So if I have a 10-item assessment that I'm creating, I'll have 40 items then. And each of the items will be asked in 4 different ways that are similar. And what I do then is I compare those 4 scores to see if they're the same. And typically what I do then is I take the 2 items that were highly correlated with each other, score-wise, and then I take those 2 as the items that are most understandable because that is where people scored most likely exactly the same. Does that make sense? Use selected responses, multiple choices, instead of constructed responses or essay items, right? I mean, think about that. That is, essay items are some of the more difficult to score. And so that's when we talk about quantitative versus qualitative. Quantitative tells us that something has changed. Qualitative tells us why it is. So you could have a mixture of them, but when you have essay items, it's a lot tougher and it reduces your reliability greatly. Why is that? Why is writing essays or writing any type of response going to reduce your reliability?
Because there's no concrete way to measure that on a scale.
There's no concrete way to measure it, although Pearson, right down here, have created a way to score the essay portion of the GRE through computers. Right? They used to have, you could be a GRE reviewer, and you would go in and get paid to review the essay portion. No longer, they don't do it that often anymore because they have a computer that does that. So we have computers that can look at essays and find out what should be in the portion. But why does it decrease reliability? That would be reader-iterator reliability. If we're using a computer, it's going to be, what's that?
There's gonna be like an error in content because it's, you know, when it's multiple choice, there's just one answer.
Right.
But when it's an essay, you're looking at the content of it.
Mm-hmm.
So reliability on it's just gonna go down because it's gonna change, vary so much
Mm-hmm.
from person to person. You're not gonna get to people that are gonna write specifically the same thing.
Yeah, exactly. And why is that? Yeah, exactly. Because we all have different writing abilities, right? Great. You're in grad school. We don't take tests anymore. You write papers. Does that mean that everybody writes A papers? A-level papers, I should say. Is it A-level paper in grad school different than an A-level paper in undergrad? Oh, yeah. Way different, right? And so, will everybody who takes our test be graduate students? Depends. But if it's a general test, no. So there's a lot that can go in that can really, really mess up your reliability, where you're right, if we're just asking questions, you either get it right or you get it wrong. That's it, it's multiple choice. Ensure items are not too difficult or they're not too easy. Provide clearly stated administration and scoring procedures. Wait till we get to the comments. And require training before individuals can administer, grade, or interpret the test, which is why you're in this class. Cool. Questions, concerns, or comments?
Why does the standard error decreases when you are like closer to the mean, whereas you have a larger like you have when it's further out from the mean, you have a higher confidence level. That's what I meant. You have a higher confidence level, but as you get closer to the mean, your confidence level is lower.
Right, right. So if I were to draw an eraser. Right, if I'm going to draw a scale right here of 0 to 100, what are the chances, and let's say that, so I give you guys a test, 0 to 100, and the mean of the test is 78. Is that good with everybody? All right, cool. What is the confidence interval, or what is the chance that you will score between 0 and 100? 100%. Absolutely. You have a 100% chance that you will fall between 0 and 100 on this test because you're either doing it and you get a score or you don't do it and you get a 0. The closer we have to come to predict exactly what is going on. So if I say, then what do you think that your chances of getting between a 50 and a 100 on the test?
To be able to tell you.
So it's going to be a lot different because we're starting to decrease, and because we don't know standard error, because we don't know all the stats that we're looking at. The smaller the area that we're looking at, the less confidence it is that we're actually going to get into that area. If that makes sense. Unless we're retesting, right? If I retest you 65 times and your individual score is a 78, and I know that you fluctuate between 75 and 80, then we could say that this area here, you have a confidence interval of 95% because 95% of the time you fell between that. Right? So there's different ways that we can look at confidence intervals when we're talking about whether we're talking about groups or individuals. Does that make sense?
Yeah, I mean, it makes sense, but now you kind of like,
I know.
yeah, we explained the first one, but then like, now you kind of like mixed it, because first I understood, okay, now I understand why the greater the variability, like the higher, the greater the confidence interval, the more confident you feel about it. But then now you just said like a really small range, and you said 95%.
Because the first one, what we're measuring against is a group of people, right? Where do you fall within the group? Where do you fall within with the group of participants, right? You're going to fall between X and Y, and you have this chance to get within. you have a confidence interval falling between. But when we're talking about an individual who has taken tests multiple times, we can then take and do a different type of measuring, finding confidence interval where they would fall within the normal range of their scores.
So the 95% would actually include close to 3 standard deviations up and down?
No,
Of that person?
no,
I mean, a standard, because that's what how I'm seeing.
yeah, no. It would fall between wherever, however often you're falling between those. So let's say that your range is actually, so we could do the same 75 to 80, but most of the time you're actually falling outside of that, your confidence interval starts to shrink greatly. Because the confidence interval of you getting within that small area is greatly diminished if you have outliers or you're beyond that. So don't think about normal bell curves when we're talking about confidence intervals.
It's just when they had it calculated, when they showed it in the book and stuff like that about the confidence interval, they had those like the mean is 0 and then confidence interval 1, 2, 3 and higher. But then now you just kind of like, I'm still trying to figure out the last one you just mentioned.
And you can talk about confidence, but you can also talk about, and we've talked about this from the very beginning, the confidence intervals in the standard bell curve as well, right? And so between 1 standard deviation plus 1 standard deviation minus is how much? 68%. So the confidence interval falling in between that is 68%, and then going on and on out. But you could also do the inverse as well with it. And so you could look at different sections of it, or you could say how many would actually fall, what's the confidence of falling into this just by doing simple mathematics. Stats. They're wonderful. All right. And then the copyright, that means that we're done with this section. Woohoo. Do we need to take a break before the next lecture? Yeah, okay. All right, let's take a break, and then we will get into validity. And let's see if I can pause this.